Hello everyone, my name is Emily Leba, and I actually chose a third grade science TEK, and that is over force, motion, and energy. So these students are expected to determine how different forces may impact how an object's position may change. And the essential question I had for students is, how can a force impact the position of an object at rest? Simply put, so in doing so, the students will demonstrate force by pushing and pulling their own chairs to determine how a chair's position may change when the force is applied. And I believe this is really, it's really important for the students to become engaged in their own learning process. So by using their chairs that they sit in every day, I feel like this can really help them, so they will get involved in the actual learning process. So they will push the chair, see how it moves when they push it, and then they'll pull it back. And then they'll be able to, explain, oh, well, I pushed it, so I caused that chair to move. And I pulled that chair back, so it moved again. So they can understand how the different forces may impact that object's movement and how, the position may change. By becoming engaged in the lesson, they're getting a better understanding, and by understanding the, how the position of the object may change, they're understanding a little bit more like, oh, well, that force is being applied, so it's going to change. The position is going to change. They're not simply just learning facts, like, oh, okay, if that hits, if that object hits that other one, it might move. No, they are actually becoming engaged in the process. In Understanding by Design, on page 39, Wiggins and McTighe actually state, understanding is the ability to marshal skills and facts wisely and appropriately through effective application, analysis, synthesis, and evaluation. Doing something incorrectly, therefore, is not by itself evidence of understanding. It might have been an accident or done by rote. To understand is to have done it in the right way, often reflected in being able to explain why a particular skill, approach, or body of language is or is not appropriate in the particular situation. By understanding what the students are doing, they are, they're able to comprehend, okay, if this object hits this one, or if I push my chair or pull it in, the position is going to change. They're not simply just expecting, oh, well, if Sally pushes her chair, it's not going to move. No. Sally's chair is going to move because Sally's pushing that force into the, into the chair. So the chair is going to move. Later in the lesson, the students will actually learn about Newton's law and what a Newton's cradle is, and then they'll create a Newton's cradle of their own by tying a ball or two balls with a string on each end, or one in the middle and one on the end. They'll pull one back from certain heights, different heights. They'll record their data, and they'll determine, how that object is going to move when that first ball hits the second one. It's going to move. And through this experiment, they can determine, okay, well, that object moved from this height, and it moved, this much. And they'll work together to kind of determine, okay, well, if this force is applied, then that's going to move this much. And it just really helps them when they're engaged and they get a better understanding of what they're learning.